Dear student, in previous video, I explained about the retropericyclic reactions. Now, in this video, I am going to share with you carbon-oxygen and carbon-nitrogen disconnection. So, this is the first target molecule. In this target molecule, so you can see here, there is a carbon-oxygen linking. So, whenever a carbon heteroatom linkage is there, we have to always first of all focus on carbon heteroatom disconnection. So in carbon heteroatom disconnection, we have two possibilities. Either we can disconnect here in the direction of oxygen, or we can disconnect here in the direction of oxygen. So as oxygen is electronegative, therefore always we have to break a carbon-oxygen bond in the direction of oxygen. But the best method is to disconnect this. I mentioned this as a disconnection, and this one is the B disconnection. The best disconnection is the A disconnection. The reason behind is you can easily get the phenoxide after this disconnection. So because of that, this is the best disconnection. So it gives you a phenoxide. So phenoxide, the retro, this is phenol in presence of base. Now the charge, whatever the charge is generated here, that is a positive charge, that positive charge is generated, and positive charge, whenever it is on alkyl carbon, you simply write down the leaving group Br. Now, whenever a Br is there, then you have to always go for the FGI. So go for FGI, and Br we have to replace it with a hydroxy group. So write down the hydroxy group over there. Now, whenever a hydroxy group is, that is, you ask the question to the target molecule, what type of hydroxy group it is. Now, this is the primary hydroxy group. So, whenever a primary hydroxy group is there, again, you always do the FGI because of what? So, instead of hydroxy group, the group which we have placed over here is ester functional group. So, whenever a carbonyl group is there, now consider this is the new target molecule. Whenever a carbonyl group is there, the best disconnection, this is the alpha carbon. The best disconnection is always next to the alpha carbon in the direction of alpha carbon. So this is the best disconnection. So what synthone you are getting? A donor synthone here, COET, that is CH2 minus COET. The best synthetic equivalent for the CH2 minus COET is diethyl malonate. So the remaining part, the positive synthone here obtained, that is there is a positive charge on this carbon. So because of that, again a positive charge on alkyl carbon. So simply you write down the leaving group as Br. And this is what? This is uh, the carbon which is next to the vinylic carbon. This carbon is called as a allyl carbon. So it is very easy step to have a allyl bromide. So that can be done by doing a reaction with this 1-propene with NBS. So allylic halogenation can be possible by using N-bromosuccinamide. So no need to go retrob this. So diethyl malonate, treat it with sodium ethoxide in presence of ethanol. That you always remember, the solvent is ethanol here. That proton, this proton is abstracted by the base. So this proton is abstracted by the base, and then after attack of this, then you have to attack it on the and depart the leaving group. So this is the mechanism. So after this, you don't want two ester group. So acid hydrolysis reaction. After acid hydrolysis, both the groups converted to COH, and then the next step is again the heating. Due to heating, there is minus CO2. So after decarboxylation, the next step is again the esterification. So it gives us back to ester group. Now that ester group is reduced by lithium aluminum hydride to CH2OH, so it gives you CH2OH. Now this OH is replaced by Br, so the reagent used for this is PBr3. After that, the phenoxide ion, so it attack here and depart the leaving group. So this can be obtained by phenol plus NaOH. So that gives the target molecule plus NaOH. Now this is the next target molecule. Here there is a carbon-nitrogen bond. So in previous example, what we discussed, that is there is a carbon-oxygen bond. Now here there is a carbon-nitrogen bond. Whenever you have a carbon-nitrogen bond, that is a amine functional group, the first question that you have to ask to the target molecule, is it primary amine, secondary amine, or tertiary amine? So whenever the secondary or tertiary amine is the answer, then you always go with the FGI, and that FGI is placement of carbonyl group. So that you always remember, whenever a tertiary or secondary or tertiary carbonyl group is there, you go with the FGI. FGI is what? Next carbon, you have to write down the carbonyl group. So the carbon which is next to the nitrogen, there you have to write down the carbonyl group. The reason behind is the secondary amine, if you are not reduce the reactivity of this nitrogen functional group, then again it can react with one more alkyl group because still there is electron pair. So instead of monoalkylation, you have a polyalkylation product. So secondary amine, at the end, it gets converted into a quaternary ammonium salt. To avoid this, what we had to do, we had to place the carbonyl group there. So due to what? Due to the placement of carbonyl group, you can see now the reactivity of nitrogen is ruled out due to this type of a resonance. So once the reactivity is reduced, now nitrogen no more reactive towards one more alkylation. So you can see here, the due to this resonance, the reactivity of this nitrogen group get reduced. So look at here. Now where we have to disconnect, again the same in the direction of what? In the direction of nitrogen, always in the direction of heteroatom. But prior to that, what we had to do, we had to place the carbonyl group here. So the placement of carbonyl group is here. So what we had to do, so whatever the target molecule is there, so this is the target molecule that write down on the arrow, FGI, and on FGI you write down the carbonyl group there. So after writing down the carbonyl group there, then you disconnect a nitrogen and carbonyl carbon, the bond between these two, you disconnect in the direction of nitrogen. So simply the synthetic equivalent for PHNH minus is PHNH2, and the synthetic equivalent for CO plus CH2CH3, just you simply place the leaving group Cl. So acid chloride plus aniline, it gives the amide first of all, but in the target molecule, as there is no carbonyl group, so that carbonyl group we have to reduce it with the lithium aluminum hydride, and after the reduction of this, that gives the target molecule. So here, how the reaction that takes place with the lithium aluminum hydride. So lithium aluminum hydride, one of the hydride is transferred toward this carbonyl carbon. So this carbonyl carbon, so that this changes to O minus. Next step is what? In the next step, that O minus react with, that is 3 times the reaction takes place. The reason behind is we have a lithium aluminum hydride, that is still more hydrides are there. So it gives such type of product, that is two R groups are there. Now in the next step, this nitrogen electron pair forms a double bond here, and so that OAlR2 group is going to depart. And at the end, one more hydride can attack here and neutralize the charge on nitrogen. So in that way, carbonyl group is reduced to CH2 group. So LH can be used for the conversion of carbonyl to CH2. Now this is the new target molecule. In this target molecule, first question that we have to ask to the target molecule, what type of, as there is a nitrogen, so as I already explained you in previous example, that what type of amine. So now here it is a tertiary amine, correct? So tertiary amine is there. So what is the first strategy that we have to follow? FGI. And FGI is what? Plus the carbonyl group. So placement of carbonyl group is possible at this position only. So write down the carbonyl group here. And the next step is disconnect the bond, carbon nitrogen disconnection in the direction of nitrogen. So after this, it gives acid chloride plus dimethyl amine. So acid chloride, you can again go the retro of this is FGI. So FGI, what you are getting? After FGI, it gives COH. So this COCl converted to COH. And what type of COH it is? It is RCOH. Whenever it is RCOH, then best one is what? Retro-Grignard reaction. So retro-Grignard is what? You can see the in the synthesis, cyclohexyl bromide, treat it with magnesium first, and that it gives cyclohexyl magnesium bromide. Then you attack it on carbon dioxide. So it gives you cyclohexane carboxylic acid. After this, you treat it with thionyl chloride. So acid is converted to acid chloride. So it gives COCl. After this, that you have to treat it with secondary amine, that is dimethyl amine. The reaction takes place between these two so that it gives a carbonyl group here and the reactivity of nitrogen get reduced. After, at the end of this carbonyl group, we had to reduce it to CH2 group by using a lithium aluminum hydride. So that gives the target molecule. Now this is the next one. So rather than, if in previous example, what we discussed in previous two examples, we discussed about the one example is of secondary amine, the another example is of tertiary amine. Now you can see here, there is a primary amine, this one is a primary amine and this one is a primary amine. So whenever a primary amine is there, then these are the different routes, that is oxime, nitriles and nitro compound. These are the three possibilities, we have to go with that. So whenever a NH2 group, that is a primary amine group is there, then always we have to go, no doubt we have to go with the FGI only. But FGI, either we can place a oxime group or we can place a cyano group or we can place a nitro group. So when we can place a cyano group, if you have a CH2NH2 group, if you are having the CH2NH2 group, then you always first of all go with the FGI as it is a primary amine. So whenever a primary amine is there, you always remember whether we had to write down the oxime, nitrile or nitro compound. Oh, these are the three strategies that we had to follow. So now again, how we can identify whether we have to go with the oxime or we have to go with the nitrile or we have to go with the nitro compound. So look at here. In case of a nitrile, that is when we are going to place the cyano group. So for that, important is what we must have a CH2 NH2 group in the target molecule. If it is there, then you go with the cyano group. Now look at the nitro group. So whenever you have a RNH2 group, so RNH, this is a different, this is RCH2NH2, this is RNH2 group. That means in between R and NH2, the CH2 group is not there. So that group is not there. So whenever that is the case, you always, instead of NH2, you always place the nitro group. So placement of nitro is when it is possible, simply the R group is there and in between R and NH2, there is no CH2 group, then we have to go with the placement of nitro group as a FGI. So now look at the oxime. So here, the nitrogen next to that carbon. So this is the next to that carbon, and this carbon, there are two different R groups. These two different R groups, either they are same or they can be different. So anyway, we either they R1 R1 or R1 R2. So if that is the case, then always go with the retro oxime reaction. So you place the oxime, and as you know, oximes are obtained by ketone, which is treated with hydroxyl amine. So oximes are reduced by lithium. These are the different options how we can reduce oxime to CHNH2. So lithium aluminum hydride, this is the first reagent that we can use for the reduction of oxime, or we can go with the dissolving metal, that means sodium in presence of ethanol. So if you are going for with the cyno group, if the cyno group is there, again that cyno group we can reduce it by lithium aluminum hydride, or we can reduce it with the H2 palladium. And if there is a NO2 group, then NO2 group we have all the options open. Either you go with lithium aluminum hydride, or sodium in presence of ethanol, or H2 palladium. So these are the options how we can convert oxime into NH2, cyano into CH2NH2, NO2 into NH2. Let us we discuss some problems regarding these different functional groups. Now this is the first target molecule. Now in this target molecule, as I told you, you first whenever you look at the target molecule, you ask the first question to the target molecule, which functional group is there, and your answer for this is, you can see here, a nitrogen group. Whenever a nitrogen group is amine group is there, your next question that you have to ask to this target molecule, is it primary, secondary, or tertiary? So now here it is secondary. That if there is a secondary secondary amine group is there, then always we have to go with the FGI, and that FGI is the placement of carbonyl group. So where you can place the carbonyl group? So only this is the place where we can place the carbonyl group. We cannot place the carbonyl group here. So we cannot write down the carbonyl because it is already more substituted. So only the position where we can place the carbonyl group here. So FGI is what? Place the carbonyl, because it is a secondary amine. So after placement of carbonyl group there, next your duty is to disconnect the carbon-oxygen bond in the direction of nitrogen. So from this it gives a acid chloride, that is benzoyl chloride, and the remaining is now which amine is generated. Now consider this is the new target molecule. This new target molecule, that again you ask the question to the target molecule, what type of amine it is. Now this is a primary amine. Whenever a primary amine is there, always we have to think about whether we can place a oxime group, nitro group, or cyano group. As in previous slide, I already explained, NH2 group, next carbon, if there are two different R groups are there, then the best method is the placement of oxime group. So you go with the placement of oxime group. So that you go with the placement of oxime group. So what you have to write here, that is pH double bond N OH. So go with this. So that here it is one more isopropyl group, and oximes are obtained by which reaction? That is, there has to be a carbonyl group. So that you write down, that you can see here, that oximes are obtained from this carbonyl group. Now you can see this carbonyl group is what? Now this keto group is attached to the aromatic carbon. Therefore, you can go with the retro FC acylation reaction. So you disconnect the bond in the direction of phenyl ring. So it gives a benzene plus acid chloride. So this acid chloride, if you want to go retro of this, so you can still go the retro of this, that is acid chlorides are obtained from acid, and this is RCOH. So you can still go retro of, that is RCOH, that is retrogrignard reaction. So Now look at the synthesis. So this acid chloride, it is treated with the benzene in presence of LCl3. Write down it is FC reaction. Then it gives a aromatic ketone. After getting the aromatic ketone, then we had to treat it with the hydroxyl amine, that is NH2OH, in presence of acidic condition. And once you get the oxime here, after getting the oxime, that oxime is reduced by lithium aluminum hydride so that it gives primary amine. Then primary amine is treated with benzoyl chloride. So after benzoyl chloride, whatever the carbonyl group is there, that carbonyl group is reduced by LAH, and that gives the target molecule. Now the next one is the nitrile group. So here look at what type of functional group here it is. Again, a NH2 group, that is a primary amine group is there. And whenever a primary amine, we have to think about oxime, so nitrile root or the nitro root. So as I already explained, we cannot apply here oxime root because we don't have next to that carbon two different R group. So instead of that, what you can see here, there is a presence of CH2NH2 group. So whenever a CH2NH2 group is there, so simply first route we had to follow is the retronitrile route. So write down HGI, and instead of CH2NH2 group, what you have to write here? Cyno group. So CH2CN. So that is the first FGI, CH2CN. The next, CN is always a donor. So next step is the disconnect a this carbon-carbon disconnection. After this, so positive charge is generated here. So cyno group act as a nucleophile, and this positive charge is here. So simply write down the CH2Cl. Next step is what? That CH2Cl that can be attack readily if the ring is donor. So you disconnect the bond in the direction of aromatic carbon. So it gives this plus formaldehyde in presence of H plus. So you can go still retrobe this, that is carbon oxygen disconnection. So you can disconnect this bond, you can disconnect this bond. So that is you have to start the reaction with the catechol, and catechol is treated with first of all sodium hydroxide, and then it is once you get the sodium salt of catechol, then you have to treat it with the dimethyl sulfate. So in that way we can go for the methylation of catechol. Once you do the methylation of catechol, the next step is what? Then you go with the reaction with formaldehyde and HCl. So this is the nitrile route. But look at the second route, that is the nitro route. Now, instead of NH2 group, we can also place simply a nitro group here. So after placement of nitro group, the next one is, again we have to go with the FGI. So FGI is what? We are going to place a double bond here. So it gives like a alpha beta unsaturated carbonyl compound. So we disconnect this bond, and on the beta carbon, so this is a beta carbon, on the beta carbon you place the carbonyl group. So this is nothing but the donor is nitromethane, that we have to treat it with the base. So due to treatment with the base, we'll get a negative charge on negative charge on this group, that is CH2 minus, and this carbonyl carbon is the acceptor. So we can go with this method also. And again, if you want to go the retro of this, so this is the retro formylation reaction. That means retro will smear reaction. So we can go with the retro will smear reaction, and again you will get the same catechol from that. Now this is the new target molecule. Now in this target molecule, so look at the target molecule and then identify the what type of functional group. So functional group is NH2, and that NH2 group is the primary NH2 group. If it is a primary NH2 group, then we have to think about the three routes, that is the oxime, cyno, and that is the NO2 group. Now here, no doubt these are the two different R group, but as these are the ring bonds, so we are not going to do the that is the FGI with oxime group. So we having only this possibility, that is the RNH2. So whenever our NH2 group is there, the best thing is what? Place the NO2 group. So FGI is place the, instead of NH2, you place the NO2 group. Now, this is the NO2 group, we call it is an electron withdrawing group, and electron withdrawing group is there on the 6-membered ring carbon. So whenever an electron withdrawing group is there on the 6-membered ring carbon, so we can easily go with the retro Diels-Alder reaction. For but Diels-Alder reaction, we need a endocyclic double bond, which is exactly anti to this position, anti to the whatever the electron withdrawing group is there, anti to that we want a double bond. So for this, to go with the next route, first one is FGI. So you place the double bond here. Now you can go with the retro-Diels-Alder reaction. So you reorganize the double bond and it ring is going to open up, that is 1,3-butadiene plus this. Look at the stereochemistry. This is a above the plane and this one is the below the plane. That is the stereochemistry is trans here. So that stereochemistry that we have to maintain across the double bond. So it is PH, CH, double bond CH, NO2. Just now we discussed how do you get this? That is benzaldehyde plus nitromethane in presence of base. So look at the synthesis. Benzaldehyde, nitromethane in presence of base, it gives a trans double bond, and then we have to treat it with the 1,3-butadiene. The condition is heating and it is a Diels-Alder reaction. After adduct, it gives this adduct. Next duty is you don't want this double bond. This double bond we had to reduce. At the same time, this NO2 group also we had to reduce, and that can be done by the reaction with H2 palladium carbon. So that double bond and NO2 group reduce at the same time, it gives the target molecule. Now this is the new target molecule. You can see here again, whenever a target molecule is there, first you identify the functional group, and the functional group is what? It is secondary amine. So whenever a secondary amine group is there, then go with the FGI. FGI means you have to place the carbonyl group. So either you place the carbonyl group here or here, that doesn't matter because it is a symmetric one. So for this entire group, it is written as AR. Same from this side, it is written as AR. So now the best disconnection after placement of carbonyl group, the best disconnection is towards the nitrogen. So it gives ArCH2, CH2, NH2, ArCH2, CH2, NH2, plus on the other side, it gives acid chloride, that is ArCOCl. ArCOCl, that is the next retro of this is ArCHO. And just now we discussed in previous example, so how we go with the ArCH2, CH2, NH2. So here that CH2, NH2 that we have to replace with the cyano group. So next retro of this is ArCH2, CN. So ArCH2Cn, next retro of this one is the disconnect this bond in the direction of this. So it gives what? ArCH2Cl. So how to get ArCH2Cl? So again, that we already discussed in previous example, that is ARH group plus formaldehyde in presence of HCl. And look at here, this part is ArCH2COH, ArCH2COH, the cyano group. If we reduce the cyano, then it gives CH2NH2. If we hydrolyze the cyano, then we get the COH group. So both these are giving the same synthetic equivalent. And look at here now, this is the starting compound, then do the reaction with formaldehyde in presence of HCl. So it gives CH2Cl. After that, treat it with cyanide. Then it gives CH2CN. And here, this cyano group, you can reduce the cyano group to CH2NH2. So this is the first of all, convert it into a CH2NH2. Now, The same we have to hydrolyze. The cyano group is hydrolyzed, that is acid hydrolysis. So that cyano group is hydrolyzed to COH group. Next step is what? That COH group, you have to convert it into acid chloride. So treat it with PCl5, it gives the acid chloride. So the combination of this, now at the end, the combination of these two gives you the target molecule. And after getting the target molecule, this carbonyl group, we have this carbonyl group here, that carbonyl group is reduced by LH. So at the end, we have to go with the LH, so that gives the target molecule. So please, you refer the same book, that is the Stuart Warren.